Hello, science fans. Mr. Walsh here. I have a little demonstration which will hopefully help you understand why it is hotter in the summertime and colder in the winter. The sun is always the same old sun. It's not like in the wintertime the sun is weaker and it's sending out less solar energy to us. And then summertime comes along and it just gets much stronger. It's a much brighter source of solar energy. No, it's always the same. So, if it's always the same old sun sending out the same amount of solar energy to us, then how can it be that it is so much colder in winter and hotter in summer? Let's find out.
Okay, here we have my unreasonable facsimile of the Earth and Sun. And this line going straight through the center of the Earth is the Earth's axis. It's an imaginary line around which the Earth rotates or spins. The little dot is the area of the Earth where I live, which is New York in the USA. So, as the Earth is revolving around the Sun, it is not perpendicular to the sun. It is not straight up and down like this. It actually leans at an angle of about 23.5 degrees, which means in the wintertime, this spot of the Earth where I live, New York, is leaning away from the sun. That's wintertime. When it comes around to the other side, it's going to be leaning towards the sun. Ta-da! Like that. The result is that in the wintertime, our part of the Earth in New York is leaning away from the sun, so we're getting less solar energy. And in the summertime, we are leaning towards the sun and getting more solar energy. Let's look at why that is true. Because the Earth is leaning at an angle of about 23.5 degrees, what happens is in the summertime, New York is leaning towards the sun. Now, if you look where the sun rays are shining most directly at us, that is going to mean that from the spot where the sun hits us directly and the spot where we are, that's going to be an angle of about 24 degrees. And then in the wintertime, if you look at the spot where the sun is hitting us directly, and you look at that angle, how far we are from that, that is about 72 degrees in New York. In spring and fall, it's about 46 degrees. And that, my friends, makes all the difference. Let's look at how. Now, I'm going to need something to represent solar energy. What can I use that I can show the same amount of solar energy hitting our part of the Earth differently? Oh, I know what. I'll use some candy. I will be using this flashlight to represent the sun, and this printed protractor to show us the different angles the sun is going to be shining at. And here's the candy. I have used 28 Junior Mints to represent the sun's energy, and we'll see how it is distributed in the different seasons. In the wintertime, the sun's energy is hitting us at an angle, and so it is spread out over this whole area here. It is the same amount of sunlight. It's not more sunlight or less sunlight. It's the same old sun, but it's just shining at an angle, which makes it spread out all the way from here, all the way across this whole area. So if you were standing in any one spot on Earth, how much solar radiation would you got? Well, if we're using these Junior Mints to represent the solar radiation, any one spot, you would get 1 Junior Mint. That's not a lot of solar radiation. So if we were standing in this one spot on Earth, I take this one. If you're in one spot, you're only getting a very small amount of solar radiation represented by this Junior Mint. I don't want to waste it. What am I going to do? I guess I'll have to eat it. That's really good. I'm sorry, I wish I had some for you guys. I feel terrible. Anyway, back to the lesson. Okay, so that was winter. In the spring and the fall, the angle the sun is striking the Earth is much greater. So let's see how that affects things. Now, with this much greater angle that the sun is striking the Earth, we had the same amount of solar radiation, which I am using 28 junior mints to represent once again. But now, they're not spread out all over the place. They're concentrated in a smaller area. It's the same amount of solar radiation. I haven't changed the flashlight at all. I'm just shining it from a different angle. And so all the light is hitting in this smaller area. So now if you're standing in any one area on the Earth, a lot more of the solar radiation is going to hit you because it's concentrated in this small spot. Let's take a look. So now, in the spring or the fall, any one spot that you're standing in will not just give you 1 unit of solar radiation. Look at that. They're concentrated. Now, there are 2 candies for each spot. You're still standing in one spot. You're still having the same sun shine on the Earth, but that radiation is hitting at a much higher angle, so it's concentrated more directly at us, and this stands for the solar radiation. Well, I can't let these go to waste, can I? That would be terrible. I hope you guys appreciate what I'm willing to do for you. I mean, this is a real sacrifice. I will eat them so that they don't go to waste, but don't worry. I'll tell you how delicious it is. Oh, that's really, really good. Oh, that's delicious. I hope you guys appreciate this. Okay, let's move on. Now, moving on to summertime, we're leaning towards the sun now, so the sun is hitting us at a much higher angle, which means the solar energy is really concentrated. It is going straight at us. It's the same amount of solar radiation. I am still using 28 junior mints to represent this, but now, because the sun is concentrated directly at us, if you are standing in any one specific spot on Earth, you would have a lot more solar radiation hitting you in your exact spot. So, for example, here, using my 28 junior mints as an example, standing in any one spot this time in summertime now has 4 units of solar radiation. It is the same amount of solar radiation we started with. I'm using 28 junior mints to represent them. But now, because the angle of the sun is so much greater, it is concentrated going straight at us. Any one spot on Earth has a lot more solar radiation. That is why it's so much warmer. I know what you're thinking. You're thinking, Mr. Walsh, I'm very concerned. I don't want that candy to go to waste. I know you need to use it for an experiment, but you shouldn't waste things. I know. I agree. And I hope you guys appreciate this. I am willing to sacrifice for you. I will eat these so that they don't go to waste. But don't worry. I will tell you how delicious they are. Okay? 4 junior mints. That's so good. That is delicious. Oh, wow. I really hope you guys appreciate this. You see how I'm willing to suffer for you? I'm really sacrificing here to teach you. Hi, Floppy. What? Do you believe this guy? What? Oh, it's okay, Floppy. I was just doing a demonstration for him because I care about them so much. Talk to the paw.